Good evening to all. In the last Wednesday class, I started circle chapter. We were discussing about the properties of the circles and about the tangents, definition of a tangent and secant, and also based on the circle property, how it is correlated to present standard syllabus, that is a chapter that we are going to know. So in the last class I highlighted two properties. One property is the radius drawn from the center is perpendicular to the point of contact. So in textbook it is theorem 10.1. The radius drawn from a center is perpendicular to the point of contact. So many times we use this property. So based on this theorem 10.1, take the figure. Here we are drawing a tangent PT and the radius from the center is perpendicular to the point of contact. So here we use the concept of all the line segment, the perpendicular drawn from external point, perpendicular line from the center from the external point is the shortest side, right? So based on the property we are going to prove. Usually proof means you have the logic analyzing either the congruency or any other properties. Now here it is a logic thinking. Since if you show that OP is shorter than the line segment drawn from the center to the tangent, then OP is perpendicular to the point of contact. Radius drawn from the center is perpendicular to the point of contact. Is clear? Get the figure? And as theorem consists of the steps, the first step is given a circle CO, R. That means a circle with center O, radius R. A circle COR, given a circle COR in which PT is a tangent, OP is the radius drawn to the point of contact. To prove, what we have to prove? OP perpendicular to PT. The perpendicular line from the center, the radius drawn from the center is perpendicular to the point of contact. Taken? To prove is over. Next, construction. Take 2 points M and N and join OM and ON. Proof. Okay. OP equals OQ, radii of a circle. Therefore, OM is greater than OQ. Since M is a point other than point P, and we know that tangent is a line which is touching the circle exactly at point P. Apart from point P, any point is not coincide with P, that means it is some other point. That means we cannot say that is a radius. Okay, OM is greater than OQ, but OQ equals OP, which implies OM is greater than OP. OM is greater than OP. Similarly, we can take it ON is greater than OP. Therefore, OP is the shortest side. Since a segment drawn from an external point, since here you added since of all the line segment drawn from an external point, perpendicular is the shortest. This you have proved in the 9th standard, right? Perpendicular is the shortest. So here we are considering OP is less than OM, OP is less than ON. Therefore, conclude OP is perpendicular to PT. This is a logic analysis of the theorem. Here we consider when the segment is shorter, it should be a perpendicular, as we know that of all the line segment, the perpendicular from the external point is the shortest one. So finally we conclude OP is perpendicular to PT. Hence proved. Clear? Have you all taken? So in the textbook we have this theorem 10.1. According to theorem 10.1, the radius drawn from the center to the point of contact is perpendicular to the tangent. Point of contact means a point, it is intersected by the tangent. Conversely, if it is a perpendicular, the line must be tangent. Based on that, we have constructed a tangent without using center. A tangent without using center, showing, that is drawing using center, not using without using. Without using, you have one more property, that is angles in alternate segment. Here, using center, we constructed 90 degree. That shows that if it is 90 degree, it must be a tangent. If it is a tangent, it should be perpendicular. So it's a converse relation. What we did in practical way, theoretical way, we have proved it here. Is it clear? So I'll move on to the next theorem, theorem 10.2. Take the heading. Another important theorem. Most of the problem will be under this property, that is tangents drawn from an external point to a circle are equal in length. Tangents drawn from external point to a circle are equal in length. I'll check once again the statement. You write the heading theorem 10.2 and then what is the statement theorem 10.2?
The lengths of tangents drawn from an external point to a circle are equal.
Okay. Draw a circle of any radius. Take a point P outside the circle. Same concept we have proved as a construction. Take a point P outside the circle. It is a construction. So I made it as a dotted line where PA and PP are pair of tangents drawn to a circle with center O. We need to prove they are equal in measure. This is theorem 10.2. The length of tangents, theorem 10.2. The length of tangents drawn from an external point to a circle are equal. So repeat the statement again and again because we use this property to solve the problems in the textbook as an outside the textbook also. The statement is very important. The length of the tangents drawn from an external point to a circle are equal in length. Using that condition, we have verified in construction chapter construction of pair of tangents. Right? So same concept we are going to prove. It is proved by verification, by measuring. Now here it should be proved by the congruency part of the triangle what we have taken. Is clear? Taken the figure, below the figure you have to write the statement given. What is given? A circle COR. We read it as a circle with center O and radius R. Given a circle COR in which PA and PB are two tangents tangents from point P. PA and PB are two tangents drawn from point P. To prove PA equals PB. Construction. What construction we have to do? Join OA, OB and OP. Join OA, OB and OP. So now see the triangle here in the figure. We have to show the triangles are congruent. When they are congruent, then PA equals PB will be its CP/CT. To that we consider, right under the heading proof in triangle POA and triangle POB. Either you can take it as OAP, OBP, POA, POB or APO, BPO. The order should be same for both the pairs. Where we have OA equals OB, reason radii of a circle. Then angle, before that you have to write OA perpendicular to PA, OB perpendicular to PB according to theorem 10.1. Just now only we proved they are perpendicular. When they are perpendicular, we can consider angle OAP equals angle OBP, bracket each 90 degree. OP equals OP, reason common. Which congruency can we say here to prove that they are congruent? Which congruency? Which congruency can we say? Yes, the triangles are congruent by not SAS, RHS. RHS congruency. Therefore, triangle POA is congruent to triangle POB by right angle hypotenuse side. By RHS is right angle, this is hypotenuse side. RHS, and congruent, which implies PA equals PB as CP/CT. What is that CP/CT? Corresponding parts of congruent triangles. Hence, proved. Not with SAS. Side angle side is not possible. There is no included angle. It should be right angle hypotenuse side. RHS congruency. Okay? Right angle hypotenuse side. Two triangles are congruent. Most repeated, many time it is given up in the board examination. They will give two theorems, one from similar triangle and one from this. And one of the theorem, that is converse of Pythagoras theorem, they have removed. We have there two theorems they removed, area theorem and converse. We have only two theorems from similar triangle, two theorems from circle. So 4 theorems, 4 plus 4 or 3 plus 4, 7 or 8 marks in the paper. You have to do it as it is. Don't go without writing given to prove construction. and without mentioning the reason in the bracket, if you work out, you will lose the marks. How the present students are suffering after getting the result. They are telling we are expecting 95 above, we got only 85, we got only 80. Because of this halfway of answering, the teachers are very strict. Not like me, they will cut the marks. If it is not correct in second or third step, entire marks gone. So be careful while answering. Try to write the answers with the steps including the reason. Now itself start it. Don't go with the short way of answering it. Is clear? Repeatedly you have to listen what I am giving the instruction. That will help you to success. Same time, if you want means you have to listen. We know everything. Without practicing, without repeating, you cannot attend in the board exam with all the tension in your mind. So for that we require regular practice. Last class I explained these two theorem property and we did few problems. Now we'll straight away move on to the problems. The assignment, first question, second question and all. After doing few questions, I can go to these type of questions. Okay. So I will go with very simple questions. Then I will catch up these questions. 5 questions, 15 questions left. Okay. So I will move on to the textbook question. Example 1 textbook question, that is also most repeated question. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. Example 1. Take two concentric circles of different radius. Circles with same center, different radius or concentric circles. Here the chord of the larger circle is touching the smaller circle at a point. So we have to prove that it is bisected at the point of contact. And we have to recall the properties what we have learned in 9th standard. Perpendicular line from the center bisects the chord. Based on this, we are getting AB equals AB. It is bisected at point M. We have to prove AM equals BM. So here in the question, they named it as P. I will show you P here. Symbolically, I will write perpendicular. C1 and C2 are two chords. We need to prove AP equals BP. Two concentric circles, the chord of the larger circle which touches the smaller circle. When it touches the smaller circle, the chord of the larger circle will become tangent to the inner circle. Are you agree with this? When it is touching at the point of contact, that shows that it must be a tangent. When it is a tangent, according to theorem 10.1, it is perpendicular. And we know that perpendicular line from the center bisects the chord. Therefore, AP equals BP. Is it clear? This is 2 marks question. So I will start the answer under the heading solution. Not visible. It's clearly concentric circles. Okay, the end part is not clear. Anyway, you can draw 2 concentric circles. No problem. You write the answer under the heading solution because such type of question you will get for 2 marks. For 3 marks and 4 marks, we require all the steps given to prove, proof, etc. Here, AB is a chord of the larger circle C2 touching C1 at P. Therefore, APB is a what? Therefore, APB is a, come on, tell me. APB is a, APB is a tangent. When it is a tangent, we consider OP is perpendicular to APB according to theorem 10.1. The radius drawn from the center is, yes, Abhilash, you are correct. Vishal, you are perfect. OP is perpendicular to APB. When it is a tangent, then it must be perpendicular to the point of contact. And we know that perpendicular line from the center bisects the chord. This is 9th standard property. Perpendicular line from the center bisects the chord. Therefore, AP equals BP. Hence, it is bisected. Clear? Next question. I think this question I included in the worksheet also. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Next question. It is a textbook question, question number 4. I think it is in the worksheet also. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Ends of a diameter of a circle are parallel. You can also get the same question as prove that tangent at the extremities of the diameter are parallel. Instead of giving at the end of the diameter, they may mention the particular word extremities. Extremities means at the end of the diameter. If tangents are drawn, they are parallel to each other. This is also 2 marks question. Get the circle and obtain the diameter. Draw 2 tangents at the end of the diameter. So when it is a tangent drawn to the point of contact, we know that it is perpendicular to the radius drawn from the center. Then I will show that this is 90 degree, this is 90 degree. P, T, Q, Q, R, or can you okay? First I will show this is 90 degree, here I will show it is 90 degree, but they form alternate interior angles. When the alternate interior angles are equal, the lines must be, no, these two are alternate. If it is right way like this, they are co-interior. We can take like that also. Okay, even co-interior angle also satisfies. Okay, tangent drawn at the extremities of a diameter or ends of a diameter are parallel. You have to prove PT is parallel to QR. Again, write under the heading solution. Under the heading solution, given, when it is solution directly you can start your answer. Solution, a circle CO, or circle with center O, radius R, in which PT and QR are two tangents drawn at the end of a diameter PQ. PT and QR are two tangents drawn at the end of a diameter PQ. To prove, what you have to prove? To prove PT parallel to QR. Since OP perpendicular to PT, Theorem 10.1, angle OPT equals 90 degree. Take it as result 1. Next, since OQ is perpendicular to QR, we know that the tangent drawn at the point of contact is perpendicular to the radius drawn from the center. OQ is perpendicular to QR. Therefore, angle OQR is equal to 90 degree. So then you write, from the result 1 and 2, we get angle OPT equals angle OQR. OPT equals OQR. You can also take the corresponding angle sum 180 degree. For that you have to add and show that, and so instead of that I took it as an alternate interior angles. Below that you write, but these are pair of alternate interior angles. Therefore, PT is parallel to QR. When the lines are parallel intersected by a transversal, their alternate interior angles are equal. Conversely, if you show that the pair of angles are 90 degree each, they are alternate interior angles. The converse, the lines must be parallel. Is it clear? Is Aditi YR is present in the class today? Aditi YR is here? Aditi YR from NPS. Yes, very good. Shraddha from NPS. Shraddha. No. Purvit from St. Joseph. Purvit. Aditya MD from St. Joseph. Okay, I'll continue. It's clear now? Tangent drawn at the extremities of a diameter of a circle or parallel. Next question. Another very important question. Take the question with the figure and just see whether it is in the worksheet. Yes, worksheet question number 6. Question number 6 worksheet. In figure, a quadrilateral ABCD is drawn to circumscribe. These are the new terms. This year we are getting inscribe, circumscribe. Okay. With center O in such a way that the sides AB, BC, CD and DA touch the circle at the points. Prove that AB plus CD equals BC plus DA. Question number 6. Get the figure now. ABCD is a quadrilateral touching the circle. So it is circumscribed by a quadrilateral like this. In worksheet I have given the figure. A, B, C and D, P, Q, R, S. Most repeated, very important question from the textbook. Come on, take the figure. It is circumscribed a quadrilateral, or a quadrilateral is inscribed a circle. Okay, circle ಒಳಗಡೆ quadrilateral, quadrilateral ಮೇಲೆ circle. Meaning is different. Okay, here we use the concept theorem 10.2. According to 10.2, tangents drawn from external point to a circle are equal in measure. Tangents drawn from external point to a circle are equal in measure. So with the same figure you have two more questions, but don't confuse the figure. The method of asking, if it is a, instead of quadrilateral, if it is a parallelogram, we can prove that it is a rectangle or a rhombus, not a rectangle. Same thing, giving three sides, they will ask to find out one of the side having the property. That is, when a circle is circumscribed by a quadrilateral is circumscribed by a circle, then sum of the opposite sides equal. That is, AB plus CD equals BC plus DA. It is a known fact. We are going to prove. After proving that, based on the concept, we have the problems to solve. Is it clear? So here, these two are pair of tangents. Do you agree? They are tangents. AP equals AS. They are touching the circle at point P and S. Similarly, BP equals BQ, CR equals CQ, DR equals DS. So we have four set of tangent pairs. Adding the results according to the condition, we can prove that sum of the opposite sides of a quadrilateral circumscribing a circle are equal. Okay, na? Right, with the figure you write, given ABCD is a quadrilateral circumscribing a circle at P, Q, R and S respectively. To prove sum of the opposite sides are equal. AB plus BC plus AD. There is no construction part. Now we have to consider the pair of tangents. While considering the pair of tangents, you must be careful. That is, once you take the pair in LHS of this, the other part LHS should be here, so that adding you will get the opposite sides. Both AP equals AS or AS equals AP is same only, but keeping in mind that opposite side, one part in the LHS means other opposite side, that part should be in the LHS. While adding, you can easily get the whole part. Is it clear? So now, proof. AP equals AS. Tangents from point A. Result 1. Before writing the pair of tangents, you can also mention the property. What is the property? Since length of tangents from external point, from an external point are equal. This property you can mention, or after taking the pair of tangents you can mention the theorem 10.2 in the bracket. That is also okay. Similarly, AP equals AS, then BP equals BQ. Write the reason. Tangents from point B result 2. Next, CR equals CQ. I could write CQ equals CR also, but adding this part should be in the LHS, so that I will take CR equals CQ. Reason, tangents from point C. Take it as result 3. Then dr equals ds. Tangents from point D. The results what I have taken, they are according to theorem 10.2, that is length of the tangents drawn from an external point to a circle are equal. Now we have to add up. See, while taking the pair, you just see how I have taken AP, BP of this portion, CR, DR of this portion. Okay, so adding you will get AB plus CD easy. So now write here, adding the results. Adding result 1, result 2, result 3 and result 4. We get AP plus BP plus CR plus DR, BQ plus C, AS plus BQ plus CQ plus DS. Okay. Now AP plus BP is AB plus CD equals AS plus DS is AD plus BC. This is how we can prove a quadrilateral circumscribing a circle. When it circumscribes a circle, then the sum of the opposite sides are equal in measure. Check the answer, verify from the board. Clear? Question number 12 from the worksheet. O is the center of the circle. PA and PB are tangents to the circle from the point P. Prove that AO BP is a cyclic quadrilateral. It is also it's a textbook question. Question number 10. Instead of giving the lengthy statement, I have just taken the question number 10 in different way. You can also have this statement in question number 12 in the worksheet. O is the center of the circle. PA and PB are tangents to the circle from the point P. Prove that AOBP is a cyclic quadrilateral. It is the angle bounded between the, that many times I have repeated, angle bounded between the tangent from external point and the radius drawn at the point of contact or supplementary. So the same concept here it is applicable. Is a cyclic quadrilateral. I think that question is different. Question number 10. Leave space, we can do that later. Okay? Take the question number 12 from the worksheet. Somewhat clearer, that is different. So to prove it is a cyclic quadrilateral, we should have the condition, the sum of the opposite angles is supplementary. Cyclic quadrilateral means if sum of the opposite angles is supplementary, then it is said to be cyclic quadrilateral. PA and PB are the tangents drawn to the point of contact. We have to prove OAPB is a cyclic quadrilateral. To show it is a cyclic quadrilateral, if you prove opposite sides of the angle sum is 180 degree, it proves the result. Get the figure? Okay. Given, taken the figure. Question number 12 in the worksheet. Question number 12. PA and PB are two tangents from point P to a circle CO, R. To prove, what we must prove? What we must prove? Yes, which is cyclic quadrilateral? OAPB is a cyclic quadrilateral. To prove cyclic quadrilateral, if you show sum of the opposite angle is supplementary, then your proof is ready. Already we are observing these two are 90 degree according to theorem 10.1. And we know that sum of the four angles of the quadrilateral is 360 degree. Subtracting it from 180, you will get other pair is also 180 degree, then it must be a cyclic quadrilateral. Is it clear? We'll have the proof for that. Construction required. Construction join OA and OB. Proof. OA perpendicular to PA. Why OA is perpendicular to PA? What is the reason? OA is perpendicular to PA. What is the reason? For what condition we have taken OA is perpendicular to PA? Yes, theorem 10.1. According to theorem 10.1, it is perpendicular, which implies angle OAP equals 90 degree. Similarly, OB is perpendicular to PB. Reason theorem 10.1, which implies angle OBP is also 90 degree. Underline this using pencil. Then we know that sum of the four angles of a quadrilateral is 360. Subtracting the sum of these two, 90 plus 90, you will get other pair also 180 degree. We know that in a quadrilateral, angle OAP, angle APB plus angle OBP plus angle AOB equals 360 degree. This is angle sum property of a quadrilateral. Clear? But OAP is 90 degree. APB we have to show. Angle OBP 90 degree. AOB we have to combine equals 360 degree. Next line. Therefore, angle APB plus angle AOB equals 360 degree. 90 plus 90, 180. You will get again 180 degree. Then come to the conclusion. Since the sum of the opposite angles is supplementary, since the sum of opposite angles is supplementary, therefore OAPB is cyclic quadrilateral. Hence the result. Okay, it's clear. So most of the questions are based on the properties what we proved in theorem 10.1 and 10.2. So practice the theorem properly. Unless you know the concept of the theorems, those theorems, where to apply, when to apply, how to apply, it is very difficult to get the answer. Most of the questions are. So I am having again now at 5:30 one webinar. So I will conclude the class today. We will continue. If there is any change in the mostly 99%, 99.9%, you will have between 5 to 6 only. Tomorrow we continue. Okay na? Till that you practice those two theorems properly and get ready for the rest of the problems. Many questions you will get it from circles as a tricky question. We will have a discussion of this. Okay? Thank you children. We see in the tomorrow's class. What is the difference here and there?
It's
How?